we're going to talk about estimating the population parameters. So now we got to the level of inferential statistics. So this is the first step of everything. So let's say there's a population that we're interested in, and there's population mean, let's say is mu, and population standard deviation, sigma. So we want to estimate, or we want to know what is the mean of the population and what is the standard deviation of the population. But as a realistic reasons, most of the time we cannot directly investigate all the population and get the parameters of the population. Let's say the population is the height of the whole population in this country, like Korea. Like the best thing that I could do is that I can go out and investigate every single person in this country, and then I get the data and put it in the like Python or anything R, and ask to calculate the mean and standard deviation. Then like I'll be very happy with that. But it's not quite realistic, and is most of the time is almost like impossible to do so. So what we can do is that we can actually get some samples from the population, like hoping that it can represent the population well. So let's take some sample, n number of sample, right? So we took sample from the population with replacement to make every element probability to be picked the same, and um, of course like random. So yeah, that's the point, to uh, actually try to make the sample to represent the population as much as possible. So okay, let's say we got n number of elements as samples, and we got sample mean uh, x bar, and uh, sample standard deviation s, sample standard deviation. So like okay, let's focus on the mean here, because anyway we're going to talk about also about standard deviation. So let's say we're very interested in the mean of the population. So we want to infer the mean of the population by the information that we have of mean of the sample. But the thing is that we always pick the sample as random. So the numbers, or like the elements in the sample, are always picked as random. So it's always vary in every time. So when you say we picked three samples, S1, S2, S3, the mean of three samples would be all different. And this is actually a problem, because we want to infer the mean of the population with x bar, which is the mean of the sample. But if we say that, and if we know that the sample mean varies every time, then we will get every different like estimator for population mean. And like, of course we wouldn't trust that, because we know that next time if I pick one more sample and calculate the mean, then the estimator would be like different. So it's not like constant at all. So actually there's not much thing we can do with one sample because we know that it varies every time. So what we can do is that we can actually imagine the imaginary distribution of sample means distribution. So theoretically, we can demonstrate that when n, the number of sample, gets like large enough, we know that, and we're gonna demonstrate it later. We know that the mean of sample and its distribution becomes normal distribution, and the parameter of the distribution would be mu and standard deviation divided by root n, like this. So we can calculate this by ourselves, and it is known and is very like theoretically demonstrated. So even though we have only one sample mean, we can actually imagine like imaginary distribution of the sample mean, and we can do a lot of things with the distribution. So what's important for the coming videos is that how to actually get to the distribution that we want and do a lot of things and like process or like method in this distribution. So okay, so uh, thank you for watching, and we're gonna get started.